All right, well, let's go ahead and kick this off here. I'm Jonathan Bryce. I am one of the founders of the Rackspace Cloud and currently very involved in the Openstack open source cloud software project. Today, I want to talk about innovation and open source and how there's a whole wave of innovation that's being driven by open source and especially in the cloud industry right now. And I think it's something that presents a lot of opportunities for businesses and for IT departments and for startups and really just the technology industry as a whole. So as we go along, if you have any questions, there's a Q&A box at in the WebEx interface. Feel free to type in any questions you have there, and we'll try to get them answered. One of the things that we have started to see over the years is that proprietary technology is really disappearing as a long-term advantage for businesses. It used to be that if you developed a piece of proprietary technology that no one else had, you could kind of rest on that and milk high license fees and support contracts for years, even decades. But we've really seen such a rapid advancement in the quality and quantity of open source software that often proprietary technology is no longer available strictly from commercial vendors, and it's quickly copied and even improved on in the open source community. And so one of the things that we've seen in the last decade or so is that the ability of developing proprietary technology as a sustainable advantage is really disappearing. And what happens if that's what you depend on as a company is you just have to keep having hits. You think about someone like Apple who generates these amazing products and these amazing devices. They have to continue to do that over and over to stay ahead of the competition because it's something that the competition is following them so closely. And I think there are a couple of examples if you look back through the history of technology. One is Palm. Palm had a huge lead in the handheld market. They were really one of the pioneers. They had a huge market share. They had an integrated hardware and software stack, and really they have kind of just fallen off the map. And it's something that they clung to their proprietary technology for a long time. They really thought that it was going to be the difference for them, but there was this wave of innovation where these open mobile systems came, and app developers were able to create a lot of value on users' mobile phones, and it kind of really shifted the market. And Palm is probably not a ship that you'd want to tie your boat to right now if you are starting a company trying to innovate. We talked a little bit about Apple, and there's a similar scenario happening with Apple right now as well. Apple really just blew everybody away a few years ago when they opened up the smartphone market and dropped the iPhone on the world. This was a device that was so completely different from everything that had come before and so far ahead. And yet now you see what's happened with Android devices, and it's really incredible. Apple had an amazing lead in terms of market share and in terms of what the capabilities of their devices are. And yet in just a few years, Android, through an open development model, through a model that encouraged an ecosystem of hardware providers, of software developers, has really overtaken Apple, and it's been incredible to see how quickly that huge first starter advantage that Apple had has just disappeared. So I think that's something to keep in mind. And at Rackspace, we have always tried to build our business on a service promise where our customers receive this integrated stack of hardware, software, and then support and service, and it's an experience that's not just about technology. And so when we started what became the Rackspace Cloud a few years ago, we had to develop a lot of technology, and we had to write a lot of software, and it was proprietary. But over the years, we realized that this was not something that was going to be our differentiator. So what I want to talk about today and go into a little bit of detail on is Openstack. Openstack is an open source community that really is building an open source cloud operating system. And Openstack is a project that Rackspace and NASA launched in collaboration last summer. As I mentioned, we built a lot of proprietary software to power our cloud, to run it at scale with over 100,000 customers in multiple data centers, petabytes of data stored, all of these virtual machines, tens of thousands of physical machines, and so it was software that we had put a lot of effort into. But we really believe that trying to hold on to a proprietary technology advantage and build your business on it is just not a sustainable business model. And we've always been huge fans of open source. We think that it's a great way to disrupt industries and to spread technology and to drive innovation. So last year we decided to open source the software that was underneath our cloud. As we were getting ready to do this, we found out that NASA had built a similar system to power their Nebula Cloud offering, which was a cloud that was in use in the U.S. government, and they were planning on open sourcing that as well. So we were able to kind of join forces and collaborate and launch Openstack last summer. So if we wanted to kind of explain what Openstack is, there are two main parts to Openstack. There's an ecosystem, and there's the core software that actually makes up the Openstack projects. If you look at the lower half of this image here, there are three main software projects. The one that probably most people first associate with cloud computing we call OpenStack Compute. OpenStack Compute is a scalable virtualization manager that handles the provisioning of virtual machines and networking, and it does it across multiple data centers at a very large scale. That is software that came in large part from the development efforts of NASA and their Nebula Cloud. Another part of that is the OpenStack Object Storage System, and object storage is a commodity storage system that's meant to handle a very, very high volume of data and to do it in a way that is really reliable, but that is also very cost-effective. This is kind of the storage model that Amazon pioneered with S3 back in 2006, where they said, we have massive volumes of data. These data sets constantly grow. They never shrink. This data is rarely accessed or sometimes never accessed, but it could be accessed at any time, so it needs to be available. But we don't want to spend multiple dollars of CapEx per gigabyte to keep track of it. So the OpenStack Object Storage System is a storage system that distributes data across a number of commodity servers. It keeps replicas. It ensures that there's redundancy and that data is not going to get lost. And it allows you to use really cost-effective hardware, but still provide a very high level of reliability and performance for users. And the third piece, which is actually a newer part of the OpenStack project, is called the OpenStack Image Service. And the image service really kind of ties compute and object storage together. If you have a lot of virtual machines and you're managing them in an automated way, chances are that you're going to want to have some golden images, some base images that you start virtual servers from. It might be a basic Ubuntu image, or you might have made a gold standard for your web server, and now you want to stand up 10 more web servers. So the OpenStack Image Service allows you to take snapshots from running virtual machines that are running under OpenStack Compute, and then to store them onto OpenStack Object Storage, and then later on to pull them back off and start up virtual machines from them. The image service also has a number of other features. You can set it up as a public catalog of images. So if you are a software provider and you have a virtual appliance that say load balancing software, then you're able to create a virtual appliance, host a public OpenStack image service, and you'd be able to provision, or users would be able to provision, say, trial instances from your image service into an OpenStack cloud. So those are kind of the three main components of the software. Going forward, there are a number of other aspects to the overall cloud management system that are going to get built in. One that's currently being worked on is a network as a service project that will allow not just the kind of networking that you do when you are virtualizing compute, assigning IPs to a server, but really managing the network in the entire data center. So being able to really do everything above layer 1 in an automated, virtual, and API-driven way. So that's kind of the software, and that's one part of it. But the other part that's very key is there's an ecosystem that's developing around Openstack, and we'll talk a little bit more about this later in the presentation. But Openstack is built around this set of core software that is Apache 2 licensed. So it's free to use, it's free to download, it's free to modify. You can take it and turn it into a commercial offering if you want. But it's very easy to get involved with Openstack and start working with it. And so we have a lot of companies who have started to develop tools to make Openstack easier to deploy, easier to use, to add value on top, and or to build service companies that are going out and deploying OpenStack clouds inside of enterprises or with service providers. And so that ecosystem is really important. And again, that's what I think we see when we let open source drive innovation in an industry. It takes away that kind of licensing barrier and some of those barriers to entry that make it harder for startups and for innovators to get involved with the technology. And you get all of these ideas and all of these people out there who are putting their energy into it, and it really makes it grow like gangbusters. I think that if you look at Android, it's a great example of that. One of the other things to note on the OpenStack compute side is that OpenStack compute strives to be hypervisor agnostic. There's a lot of hypervisor choices out there: Hyper-V, ESX, KVM, Zen Server, and the OpenStack compute is trying to be kind of the control system, the operating system for the data center, and so because of that, one of the goals of the project is to remain hypervisor agnostic. And with our latest release, which just happened last week, OpenStack Compute now supports all of the major hypervisors, and that's another reason that I think adoption has picked up quite a bit, is because inside of enterprises or companies, these IT departments don't have to retool their entire shop and switch hypervisors and get retrained and learn an entirely new stack of software. They're able to kind of just get more out of what they already use. So the basic mission of OpenStack overall is this is the mission statement that we kind of launched with. We want to produce the ubiquitous open source cloud computing platform that meet the needs of public and private cloud providers, and simple to implement and massively scalable. So that's a pretty broad mission, and there's still a lot left to be done beyond just compute, storage, and an image service. But it's a mission that I think has resonated with a lot of people. When we started, it was Rackspace and NASA and about 20 companies who were involved to one degree or another. But over time, that's grown to 60 companies, and many of them have developers who are working full-time on the OpenStack code base. Many of them are building businesses that depend on deploying or operating OpenStack clouds, and so I think that this is a mission that people can get behind and really buy into. But in terms of innovation, why do we think that OpenStack, open source, is important? And this is kind of specific to OpenStack, but I think it applies to some of the other open cloud initiatives that have just been announced in the last couple of weeks. Really, we want to commoditize cloud orchestration. Cloud orchestration is something that is not really rocket science, but seems like everybody was building their own way to do it, and we were all reinventing the wheel rather than building the car or the airplane or the spaceship. If we can commoditize that and get a baseline of the kernel that everybody can build on top of, then you end up with a rapid rate of innovation. And the other thing too is when everyone is building it in a different way, then interoperability, being able to reuse skills across clouds, that really kind of falls by the wayside. Whereas if we can work together, kind of standardize on some technology decisions, then you end up with an interoperable and compatible set of clouds that can really leverage each other and make a lot of progress together. At the Rackspace Cloud, when we were talking with some of our customers about what they wanted, or why they would or would not use the cloud, one of the things that we heard from enterprises was that there was a fear of lock-in, that if they picked a cloud, that they would kind of be stuck with it because there were so many that were different in one way or another. What if they find out that because of compliance or security reasons they can't run on that cloud anymore? How do they move those applications back in-house? By creating software that's freely available, again, it's open source, Apache licensed, it's something that can really help address some of those fears of lock-in and security, because you can always pull it back into your enterprise or into your government agency and run it on your network under your rules and do it exactly the way that you need it done. And I mentioned a little bit about interoperability already, but one of the other things that we heard from our customers is that they had certain things that they could run in a public cloud, but there were some things that they would never be able to move outside of their walls. And so by having compatible stacks that they can run internally and run externally at a choice of service providers, then it enables this mode where IT departments are able to cloud burst, to have hybrid clouds that span their internal infrastructure and service provider infrastructure where appropriate, and it creates a lot of flexibility and a lot of power across the investments that they make. The community around Openstack has really exploded. It's something that when we launched, we were kind of expecting it to grow gradually, but it's really exploded in the last. This has only been out there for about 9 months now, but we have 60 companies who are involved in the project. Most of them have developers who are contributing to the project. Probably about a dozen of them have full-time staff that work on Openstack, including companies like Citrix and Cisco, of course, Rackspace, and so these companies are really committed to pushing Openstack forward and investing in it, and so when you have those kinds of professional developers and that kind of corporate support behind it, you're going to get what we see in this second bullet point here, where we had almost 5,000 contributions in the most recent release. And that release was about 2.5 months of development. So in 2.5 months, 5,000 contributions. There were almost 200 bug fixes. There were about 40 new features and contributions in that release from over 100 developers. So it's a community that's really flourishing and is very active. If you go on to irc.freenode.net, there's a #OpenStack IRC chat room, and that's where the developers hang out, and they're usually somewhere around 200 developers that are there talking about code, helping users. It's very vibrant and very alive. In the past few months, we've had 20,000 downloads of the Openstack software. So it's something that it's a lot of downloads. Far fewer of those are actually running production instances, but it's definitely indicative of how much interest there is in running this and trying this out and learning how it works. And another indicator of that is we do a development and design summit every 6 months, and at those summits, as many of the developers as possible come together and they plan out what is going to happen over the next 6 months. It's similar to what Ubuntu does with their Ubuntu Design Summits. And when we announced the most recent one, we opened registration for it. We ended up having to close registration 3 weeks later, and where we had about 400 people who had signed up to come to it. I think we had another 100 on the wait list by the time that we actually closed registration. So it's a community that has a lot of buzz and a lot of excitement right now. But it's not just hype. The development is really moving forward, and every week when you watch the mailing list and see what's going into the code, you see great things happening. And it's coming from a lot of companies. I mentioned a couple that are involved, Citrix and Cisco. Citrix has contributed a lot of support for their hypervisors, Zen and Zen Server, obviously, but they actually built support for VMware into it as well. They believe so much in OpenStack and in the power of having this scalable, automated way to manage data centers that they don't want anything to be a barrier to entry for enterprises. And VMware ESX support wasn't in there. That's obviously a very popular hypervisor for enterprises, and so they actually built the support in there, even though it's kind of a competing hypervisor to them. NTT Group over in Japan has a number of companies that are involved with OpenStack, and you might be aware that the IPv4 space is rapidly depleting, but it's been a crisis in Asia for a while, and so IPv6 was something that the project didn't support 6 months ago, and NTT came in and built in support for IPv6 and contributed that, and in 3 months, after they started this, the project supported IPv6, and there are all sorts of other contributions like that are happening constantly, and it's really pretty amazing to see. I've been involved in a lot of open source projects, and I've never seen one that has grown this quickly, and at the same time actually really been producing real change in the software. It's not just a bunch of people talking. There's a lot of code going into it, and so that's what it's all about at the end of the day. So the whole point of OpenStack is to take control of data centers with software, to get from the point where we're provisioning servers manually, configuring network switches manually, provisioning storage manually, doing all of these things where we have to touch servers and to automate all of it. And the thing that OpenStack also really focuses on is doing this in a scalable way with kind of a global mindset, and that comes from the background of having Rackspace's DNA in it as a service provider with data centers around the world, and then also NASA, who has a lot of different locations, and they claim to be the largest generator of data in human history. So that's a lot of data when you think about it. They capture images that are from terapixel cameras, and they store data from all of these probes that are out in space, and those are things that they rely on very heavily for scientific computing for years and years and decades. As one of the guys from NASA told us, when we lose data, we have to shoot something off into space again. It's not just a matter of rerunning some reports. It's very critical for them. So this is the I think one of the differentiators with OpenStack is that it comes from a legacy of operational reliability and scale. And when you talk about controlling a data center with software, it's something that when you have 60,000 servers, you can't be doing that manually. So this is an advance where if you wanted this kind of software 10 years ago, there was some that was out there that was available that did a pretty good job, but it had very, very hefty fees. So because of that, a lot of companies didn't implement something that was really an entire solution for their data center. They might have implemented pieces of commercial options, pieces of open source options, pieces of homegrown things, and they don't really gain the full advantages of that. And so I think that's what OpenStack enables. And as we get through the presentation, I think there's been a shift that is really going to blow the doors off of what data centers and IT departments can do going forward, in the way that we can build and operate these things at scale and at lower cost and in a more automated way. when you think about the ability to control the data center with software, especially software that, again, is freely available, high quality, developed by experts from all over the world, then I think that it really starts to open up, as I said, a wave of opportunity for innovation and for growth and for businesses to take advantage of. And I just threw a few bullet points down here. You can add whatever you think is valuable, but if you are going to build on top of this kernel that can manage 100,000 virtual machines and 15 petabytes of data, then there are obviously going to be specific scenarios where for an accounting system there might be tools that they need to ensure that data is not deleted for X number of years to comply with Sarbanes-Oxley, or different kinds of tooling that goes on top of the Openstack software to meet some vertical need, like perhaps a specific technology stack, and so there's a lot of opportunity for businesses to develop tools on top of OpenStack, on top of other open source initiatives, and add value that way. System management tools, but there are also a lot of opportunities for services as these things come along. We hear all the time from our customers that they feel like there are opportunities for them to make use of the cloud, for them to take advantage of the efficiencies and the scale and all of the automation, but they're not sure where to start. They're not sure exactly what the right application to put on there first is, and so there are companies that go and help deploy and manage these, and kind of give that guidance to enterprises and users. And then if you look at the cloud industry that's developed around the public clouds like Amazon and Rackspace, there are all sorts of products that have been built to work with those public clouds. Products like Jungle Disk and Elastic Fox and on and on. There are hundreds of them. When you are now able to help enterprises install their own private clouds, you're able to diversify from just being dependent on a Rackspace or an Amazon for your customer base. You're able to go behind the firewall and sell desktop backup clients to financial institutions who are going to insist that their backup data stays more firmly under their control. And I think this next slide here illustrates a little bit about where that benefit is for both the people who are developing software, the people who are developing services, and the enterprises who want to run clouds and who want to take advantage of it. If we live in a world where there's no standards, where there's not something that can be a freely available kernel that's easy to use, that's easy to implement, that you can run in-house, that you can make use of with service providers, then you get into this scenario in the top where, in one case, you're architecting for an in-house solution, maybe a vendor solution, and they have their specific set of APIs and they have their specific requirements around shared storage that's expensive, and you have to really get everything set up to run in that kind of mind frame and that setup. But then when you're ready to go make use of a public cloud provider, all of a sudden there's a completely different set of concepts. If you're using VMware in-house and then you want to use Rackspace or Amazon, now you've gone from a situation where you've got shared storage to a situation where you have ephemeral storage and you have to attach these block disks to your machines, and it can be kind of daunting and require a lot of effort and rework. And the idea with OpenStack and with some of these other types of open source initiatives is that they're deployed in-house, they're deployed in service providers, they're deployed all over the place, and you're able to build it once and make good use of your code, your systems, your monitoring tools, and everything else to limit the rework and re-education that you have to do. looking down here at the Q&A, I see that that Justin Anderson asked what the pricing model was. The pricing model for OpenStack is really, it's free, it's Apache licensed, so the software itself is completely free, no cost, and it's an OSI approved license. There are a number of community members in the ecosystem who are adding value in different ways to package it up as very easy to install distribution, or they're putting it on an appliance, and you can buy a ready-to-go storage node that's running OpenStack object storage. So the pricing models there vary, but the OpenStack software itself is totally free. And then Leslie Goldsmith asked what hypervisors are supported by OpenStack. So with the latest release, which just came out last week, we support all of the major hypervisors, KVM, Zen Server, VMware, ESX, Microsoft Hyper-V, as well as some of the lesser known ones, or the lesser used ones like QEMU and User Mode Linux. And one of the contributions that just came in recently was actually support for LXC, for Linux containers. And when you look at that range of virtualization technology, you see that you have a lot of options and a lot of choices to pick from, and perhaps you want full virtualization, you want to use Zen Server, you want everything completely isolated, and you can do that. You can control Zen Server hosts and provision virtual machines there, but maybe you'd like something that's thinner, that's lighter weight, and you'd rather use LXC and go with the container model. Well, it supports that as well. Again, OpenStack is kind of agnostic to what it's driving. It really it focuses on the automation of starting and stopping virtual servers, setting up networking, setting up storage, and managing all of those components of it. So this slide here has a few examples of members of the ecosystem who are able to kind of take advantage of the scenario where they're architecting once, they're building a solution once, and getting a lot of value out of it. CyberDuck is a file transfer client that's been around for a long time, and they have support for FTP and SFTP and the traditional ways that you move files around, but they also built in support for cloud storage, for Amazon's S3, and for Rackspace's cloud files. And OpenStack is compatible with actually both of those APIs. So what ends up happening is that CyberDuck is able to now leverage the work that they've already done to integrate with the largest public clouds, and they now have a tool that can work against an enterprise's private cloud and get exposure to a broader range of users. CloudKick is a monitoring company that Rackspace purchased recently, and it was built to monitor and keep track of cloud servers that are running in a number of different providers. And so it's the same kind of thing where now, because OpenStack is allowing enterprises to stand this up behind the firewall, CloudKick can now extend their reach beyond just the public cloud providers into the firewall. I think a really good example of where that's useful is with encoding.com. Encoding.com is a automated video encoding and transcoding service, and so you can take raw video and transcode it into different web formats or different TV formats, and they make use of the cloud to burst to whatever capacity you need to make that happen. But one of the things that they found with some of their customers is that their customers wanted to have local installs of encoding.com so that they wouldn't have to be shipping high-definition video over the public internet up to a cloud. If they've got a multi-hour TV episode that they are looking to transcode, that's a pretty large commitment in terms of time and bandwidth to push up to a public cloud. So now, encoding.com works with the major cloud providers and their APIs which means that with something like OpenStack, they're going to be able to work with enterprises and with TV companies that set up private clouds and do all of that within their network. InterNAP is a hosting company that has been around for quite a while, and what they've done is just recently launched a storage offering for their customers that's based on OpenStack's object storage system. And InterNAP, one of the differentiators that they have as a company is a global network that's kind of a very high performance, optimally routed network, and this is something that they've made use of within their hosting business to date. And now they are standing up OpenStack, and they're able to again take advantage of that differentiator. And for them, they knew that they needed to have a cloud offering. They knew they needed to get a storage offering out like this because their customers were asking for it. But they were looking at many months of effort to develop it internally. Whereas I believe that when they launched, they said that it probably cut their development time in about half, and I think it was 3 to 6 months from the time they started to the time that they were taking customers on a new service offering. So again, it's driving that innovation, and it's allowing customers to move faster. And this final one, cloud scaling, is a startup that's part of the OpenStack ecosystem. And what they do is they actually work with companies like InterNAP. They just finished working with Korea Telecom to set up a cloud offering in Korea, and so they have developed a business where they have services to help service providers create cloud offerings on top of OpenStack, and they are also developing technology products to extend OpenStack into specific areas that service providers need to build out a full offering. And so this is just a handful of companies that I kind of randomly picked, but there are all sorts of other companies who are involved and who see a lot of opportunity with OpenStack. And one of the big ones that was a more recent announcement was Cisco, and Cisco has put together a couple of teams that are working on OpenStack because they want to be able to have an open cloud offering to work with their customers, but they are also very convinced that going forward, networks and data centers are going to be managed in an automated way. That there's going to be a lot of virtualization taking place, and they think that there's a real opportunity to build that out within OpenStack. And I mentioned earlier that one of the projects that's getting kicked off is a networking as a service project within OpenStack. Cisco is very heavily involved in that, along with other members of the community and even other competing networking companies. So it's something that there's so much value if you look at where the market is going and how enterprises are needing to cut costs, needing to automate and become more efficient in how they manage their infrastructure, and so something like OpenStack that takes out again that kind of high license model to do basic virtualization management opens up a lot of room for companies to add value in other ways. So back to the original point that I made, I think proprietary technology really is disappearing as a sustainable advantage, and we felt this last year when we decided to take the code that we had spent millions of dollars to develop and that was running the fastest growing part of our business and basically just give it away. We really put our money where our mouth is. This is something that we truly believed. But if you look at some of the events that have happened recently, it seems like this is a movement that's catching on and that really is gaining steam. And when you look at cloud technology specifically, it's being driven more and more by open communities. When Rackspace first started, it was in the late 90s, and the web was really taking off and moving from a static HTML-driven world to dynamic, and that's when the LAMP stack really emerged as the most popular way to develop web applications by far, and it was something where the LAMP stack was a scripting language, it was an operating system, and it was a relational database. Those were all pieces of technology that had been around for decades, and open source had kind of caught up to what some of the commercial offerings could do, and became really viable as an alternative to paying a lot of money to Oracle or for Microsoft SQL, and it drove a lot of innovation in the first wave of web applications. But that had often been the progress that open source communities went through, is they kind of were fast followers of proprietary vendor started systems and technologies. And when you look at cloud, one of the things that's been really interesting to see is how the technology itself from the beginning was based off of Zen and KVM and Linux, and it's something that it's kind of been driven from the beginning by open source rather than open source following it. And just in the last couple of weeks, there have been a number of announcements that many of you probably saw, but one of the big ones was Facebook announced their Open Compute initiative, where they are taking what has traditionally, by the high-flying, hottest startups, it's traditionally been considered a proprietary advantage, the way that they build their data centers and their servers, and they are opening up all of their engineering designs for their data centers. They're opening up the designs for their servers. They are sharing these specs. They're encouraging multiple vendors to build to these specs, and encouraging people who are building data centers to build their data centers in a similar way. And it's something where you look back at some of the other really hot web companies and internet companies, and this was the kind of information that they guarded with their life. They felt that it was really important. Facebook, I think, realized that they're not in the business of just designing data centers and engineering servers. They are in the business of connecting people, and that there would be an advantage for them and for the industry overall if they opened up this piece of data. We've talked a lot about Openstack already. OpenFlow is an initiative to do something similar with networking, to be able to do massively scaled out virtual networks that are completely automated and kind of change the paradigm for how we manage networks in a data center. When you go from having a single tenant in a data center that's an enterprise that gets to decide exactly how all the VLANs are structured, to something like our environment, where we have 100,000 customers that all want their network in a different way and want a different level of separation, then you really need something like OpenFlow to make that work and scale. And then just last week, VMware announced Cloud Foundry, and I saw there was a question about platforms and platform as a service. But Cloud Foundry is a collection of technology to run Java and Rails apps and store data in a way that's scalable and automated. And Cloud Foundry is actually, there are some people who are in the community right now who are working on getting Cloud Foundry running on top of OpenStack. When Facebook announced Open Compute, some OpenStack community members were at the announcement, were actually able to take some of the Open Compute servers directly from Facebook headquarters to their apartment in San Francisco, and a few hours later they were running OpenStack on top of Open Compute. And so when you start to put all of this together, as I said here, dirt to data, you end up with the plans to build the most efficient possible data center with the most efficient possible compute nodes inside of them, with a highly scalable, free-to-use controller that interacts with an automated networking management system, and on top of all of that, you have a platform that's also Apache 2 licensed and open source, and it's the entire set of technology that you need to go from nothing to having functioning apps that are scalable and automated and just built in kind of this new cloud paradigm. So I think that's really, just besides OpenStack, when you look at the entire ecosystem, that's what's really going to drive an amazing amount of innovation and opportunity going forward in the technology industry. And what all of that means is really that we get to let the community share the work of making the basic building blocks. All of these things are really just basic must-haves, and again, they aren't going to be a differentiator over the long term. And so what companies are realizing is pool the resources and build a community, and we can all work together to build those, and then individually we can focus on building value for our users on top of all of those building blocks. So that's basically the presentation. I see there are a couple of other questions, so I will try to run through these, and feel free to keep adding questions if you've got one that hasn't been asked yet. So someone asked about KVM. KVM is a supported hypervisor. It's actually the reference hypervisor that NASA was using for their Nebula compute cloud. So it's very well supported, and is one of the most tested versions of the software. Someone asked, any idea how many are running in production? Not really. We know of several dozen that are in some form of testing or production across a wide variety of users. We have service providers. I mentioned Internet. They have a production cloud. Korea Telecom has a production cloud. There are also, obviously NASA is running this software in their Nebula cloud. There are enterprises who are running it. Some of them have not been as willing to share their names, but if you go and you do a little research and you look at who's contributing code to the project, you'll see some big enterprise names in there. You'll see that there's development that's happening from large telcos and financial services companies, and so there's a pretty broad range of use cases that are involved in deploying it and using it. That's kind of, Jerome asked about customer segmentation. It's because it's an open source community and anyone can download it and make use of it. It's hard to get real firm statistics on what the breakdown is, but it's a pretty kind of general purpose tool and piece of software, and so we've seen a lot of different use cases for it. One of the companies that we talked to recently, one of their use cases that they were looking at this for was cloud desktops. They have a lot of mobile users who have these devices that are getting smarter and smarter, and iPads and Android tablets, and these users want to have access to their desktop from wherever they are, and so that's a perfect use case for something like a cloud where you want to start up an instance and basically mount that user's home environment and let them remote into it, and then when they're done, just shut it down. So that's one of the newer ones that we just recently heard about. Christopher asked if we were looking to integrate with platform open source offerings, or do we view those mostly orthogonal? I think that there are a couple that have already integrated with us, and something like Cloud Foundry is obviously gathering a lot of attention, and as I mentioned, there are some community members who are working on integrating that as well. I think that you really get the most value when you can hook these systems together, and so I think that's the community believes that and really pushes for those kinds of things. The question though is, what do you pick, because there are so many platform options out there, and so I think from an OpenStack perspective, we don't have an official platform. We don't have an official preferred platform right now, but it's something that there are a number of community members that are working with various platform offerings to integrate them and make sure they work well together. Prim asked, how do we differentiate OpenStack from Microsoft and Google App Fabrics? So Google App Engine and Microsoft Azure are a little bit higher in the layer. OpenStack is meant to be more of the controlling layer for the primitives for getting access to raw compute and raw storage and managing networks. I think over time, as some of those platforms emerge as leaders, that there'll probably be tighter integration, and we'll see some of those that hook together. But it is a little bit different than like Azure and Google App Engine. Scott asked, how does OpenStack use, work with, or facilitate automated provisioning of resources, including within a broader context of heterogeneous resources? OpenStack is its heritage as it comes from our public cloud, and it's been built with automation in mind from the beginning. So there are APIs that allow you to manage almost every aspect of the environment. The heterogeneous nature, that if you can install one of the supported hypervisors onto that machine, then OpenStack can control it. Now if you want to really build an efficient data center, then obviously getting some similar hardware that you can manage, that you can automate even the hardware management is obviously a nice step to optimize. But if you've got legacy hardware and you want to be able to just automate the way that you use that, then as long as you can get one of those 8 supported virtualization technologies on there, then OpenStack can work with it. So someone asked when will compute be production quality released? That's actually an interesting question. When we first opened up OpenStack, we combined the compute from NASA with that was the primary basis for OpenStack, and then we've been adding in some of the components from Rackspace's compute offering. And so the compute project itself has been moving really, really rapidly, and so we've kind of been telling people that you can use it. There are companies who are running it in production, but the rate of change is very high right now, and so you have to kind of be aware of that. With this most recent release in Cactus, it really puts compute at a point where the functionality is all there. There have been a lot of bug fixes, and it's become something that's pretty stable. I think what is the pieces that are going to go into the next set of releases are around easing the management for service providers who are running at very large scale, tens of thousands of physical servers, and I think that's kind of the next optimization in making it production ready. We are basically out of time here, and I think we got to most of the questions. Let me just scan through here. Thanks a lot, everyone, for attending and for listening. And if you have any questions, you can reach me on Twitter or jbryce@rackspace.com, and I'm happy to follow up with anyone that I missed.